Barnes here. Interstellar object 3I Atlas is now hurtling through the inner solar system, being within the orbit of Mars, and it is rapidly approaching its perihelion, its closest approach to the Sun.
In October 2025, the sky above our solar system changed forever. A massive object from deep interstellar space, known as 3I/Atlas, began racing straight toward the Sun. For the first time, every telescope on Earth went blind, unable to see through the blinding glare. All we could detect was a strange pulse of light moving closer, as if the Sun itself had started to reflect something unknown. Scientists say it is a comet, but its path and behavior tell a different story. If it survives this close encounter, will we still call it a comet or something else entirely? It began quietly in July 2025, when astronomers at the Atlas survey in Hawaii noticed something unusual. A small dot on their screens was moving far too fast to belong to our solar system. Its speed was nearly 36 miles per second, faster than any comet ever recorded, and its orbit did not close around the Sun. Instead, it stretched endlessly outward, confirming that this object came from beyond our cosmic neighborhood. NASA gave it a name that would soon echo across the world: 3I/Atlas, the third interstellar visitor ever discovered. At first, it looked like a comet, faint, dusty, and red. But within weeks, the object began to change in ways that no one could explain. Its surface glowed green as it neared the inner planets, a color that usually means the presence of diatomic carbon, but the data didn't match any known spectrum. It also started ejecting a cloud rich in carbon dioxide instead of water vapor. That was strange, because in most comets, water is the main ingredient. This one seemed dry, metallic, and alive in its own way. The more scientists studied it, the less it made sense. Based on the light it reflected, 3I/Atlas might be 5 to 30 miles wide, possibly even more. That made it much larger than the two interstellar objects before it, Oumuamua and Borisov. Its structure seemed dense, almost like an alloy of nickel and iron, materials often found in the cores of planets, not in loose icy comets. And yet, there it was, racing through the inner solar system, burning brighter with every passing day. Even stranger was its direction. Unlike most comets that grow tails pushed away by sunlight, 3I/Atlas's tail pointed toward the Sun. It was as if something was pulling instead of pushing, a reversal of every rule in celestial mechanics. Some experts suggested magnetic interaction, others whispered about propulsion. None of them could prove it, but everyone agreed this was no ordinary traveler. By late September, its velocity increased to nearly 42 miles per second, and its path stayed perfectly aligned with the ecliptic plane, the same invisible sheet where all the planets orbit. Such precision was almost unnatural. Space is chaotic, filled with tiny forces that nudge and shift trajectories, yet 3I/Atlas moved like it knew exactly where it was going. It passed near the orbit of Mars without any visible deflection, continuing steadily toward the Sun. The idea of a controlled or guided object suddenly didn't sound like science fiction anymore. Every observation only deepened the mystery. It defied gravity, chemistry, and logic, everything humanity thought it knew about comets. If 3I/Atlas truly came from another star system, then it carried the fingerprints of a world we have never seen. And as it drew closer to the Sun, one question grew louder. If the laws of physics can't explain what we're seeing, then what exactly is this thing made of? On October 21st, 2025, the world entered a strange silence. 3I/Atlas had moved directly behind the Sun, reaching a position called the Superior Conjunction, and every telescope on Earth went blind. The glare of sunlight was so intense that even the James Webb Space Telescope, orbiting far beyond the Moon, could not see through it. For astronomers, this was a blackout, a complete loss of observation at the most critical moment of the entire mission. From Hawaii to Chile, observatories turned their instruments toward the Sun's edge, hoping to capture a faint trace, but there was nothing. Even the European Southern Observatory's VLT, which can detect stars billions of light-years away, reported no visible signal. The same happened at the Keck Observatory. 3I/Atlas had vanished into the light. NASA's Solar Watch satellites like SOHO and STEREO also failed to pick up its reflection. It was as if the object had been swallowed by the Sun itself. For weeks, researchers had been preparing for this moment. They calculated its trajectory, expecting the object to cross the Sun's far side at a safe distance of about 127 million miles. But no one could predict what would happen while it was hidden. During those few days, from October 21st to 29th, 3I/Atlas would be exposed to the strongest radiation and gravitational forces in the solar system. If it were made of normal material, it would break apart like dust. Yet there was also the possibility of the more haunting one that it would survive. Without direct images, scientists relied on indirect data. Solar wind readings showed strange fluctuations during the conjunction. Magnetic field sensors detected spikes that did not match any solar storm pattern. Some experts suggested these were random variations, but others wondered if 3I/Atlas itself was interacting with the Sun's energy field. Its perfectly aligned orbit made this theory hard to dismiss. The idea that something from another star could affect the Sun's magnetism sounded impossible, but so did the object itself. As days passed, news agencies stopped updating. NASA's live data feed paused. ESA released only a brief statement calling the period a temporary observational gap. But many independent astronomers were uneasy. They claimed that during the blackout, small changes appeared in the solar corona, almost like short flashes of heat. It might have been nothing, or it might have been the object reacting. No one could say for sure. By October 29th, 31/Atlas was expected to reappear on the other side of the Sun. But until that moment came, Earth remained blind. For 8 long days, humanity could only wait, unsure whether the object would emerge unchanged, broken, or transformed into something new. If it did survive that close to the Sun, what would it look like when the light finally revealed it again? When the first spectral readings of 3I/Atlas came in, scientists thought it was a mistake. The data didn't match anything ever recorded in a comet or asteroid before. Instead of showing the typical mix of frozen water, methane, and dust, its spectrum glowed with massive peaks of carbon dioxide. There was almost no trace of water, yet it behaved like an active comet, venting jets of gas into space. This single contradiction shattered everything astronomers thought they knew about how comets form and survive. At a distance where the temperature should have fallen below -330 degrees Fahrenheit, 3I/Atlas was releasing vapor as if it were boiling. NASA called it a water anomaly, a polite term for something no one could explain. Carbon dioxide can sublimate at such low temperatures, but not at the rate seen here. To produce that much energy, something inside had to be generating heat. The question was, how? When scientists modeled the energy output, they found that the object was radiating more warmth than sunlight alone could provide. The reading suggested an internal power source, or at least a process converting radiation into usable energy. This was not behavior seen in any natural body. Some theorize that the carbon dioxide jets might be driven by electromagnetic forces, perhaps triggered by the sun's field. Others proposed a more controversial idea that 3I/Atlas might not be entirely natural at all. Researchers at ESA and Caltech ran chemical simulations using the observed ratios of nickel, iron, and carbon. What they found shocked them. The blend was strikingly similar to alloys used in high-temperature engineering, the kind designed to resist radiation and heat. If that were true, it would mean 3I/Atlas was built to survive extreme environments, not just floating debris from a distant star. But how could an artificial object drift for millions of years through interstellar space and still remain intact? More mysteries followed. Its green glow wasn't the soft reflection of sunlight on ice. It came from ionized particles reacting in a structured way. Each pulse of light appeared in rhythmic intervals, suggesting some kind of pattern. Spectrographs picked up a faint modulation in the emission lines, similar to what we'd expect from an electrical discharge. The effect was weak but consistent, repeating every 11 hours, matching its suspected rotation. If these patterns weren't random, they could represent a form of signal or mechanical process happening inside the object. Still, mainstream scientists hesitated to draw such conclusions. They knew the risks of jumping from chemistry to conspiracy. Yet even the most cautious voices admitted that 3I/Atlas didn't behave like a simple rock. It absorbed radiation more efficiently than anything its size should. It emitted gases without losing visible mass. And it carried a chemical fingerprint no comet in our system could match. As it continued to approach the sun, the water anomaly deepened into something far stranger, an energetic mystery that seemed to rewrite the rules of thermodynamics. Whatever powered 3I/Atlas was hidden within, silent but unstoppable. If this was not a coincidence of chemistry, then what kind of design could make an object act like it was alive? As 3I/Atlas drew closer to the sun, the strange forces surrounding it became impossible to ignore. For months, astronomers had debated whether the object's glow came from heat or electricity. Now, as it entered the inner region of the solar system, they began to realize the answer might be both. The object was flying almost perfectly along the ecliptic plane, the same invisible track followed by all major planets. That meant it was inside the sun's strongest electromagnetic field, where invisible currents of charged particles move like a vast ocean of energy. The sun does not only emit light, it also sends out a powerful solar wind made of electrons and protons traveling millions of miles per hour. This constant storm creates an electric circuit that stretches from Mercury to beyond Pluto. Every planet, asteroid, and comet acts as a node in that circuit, shaping the balance of the solar field. But 3I/Atlas was different. It was moving directly through that current, and its alignment was almost exact, as if guided by the very forces surrounding it. When scientists compared data from NASA's STEREO and ESA's solar orbiter, they found something unusual. The magnetic field around the sun showed a series of synchronized ripples that matched the predicted position of 3I/Atlas. These waves were small, yet perfectly timed, appearing each time the object passed through areas of high plasma density. It was as though the interstellar traveler was tapping into the sun's electric heartbeat, disturbing its rhythm and then falling back into sync. Some experts called it coincidence, but others saw it as the first sign of interaction. Plasma physicists proposed that 3I/Atlas might act like a capacitor, storing energy as it moved through charged space. If its outer layer contained metal-rich materials, as earlier data suggested, it could easily conduct electricity. In theory, this would allow it to generate electric arcs powerful enough to shape its own coma and tail. That could explain why its tail pointed toward the sun instead of away from it. The object might not be pushed by sunlight, but pulled by magnetic attraction. Meanwhile, solar activity began to change. Between October 20th and October 28th, observatories recorded a sharp increase in coronal mass ejections, the giant blasts of plasma that erupt from the sun's surface. These events were more frequent and intense than usual, peaking exactly as 3I/Atlas reached its closest approach. The connection was impossible to prove, but the timing was difficult to dismiss. Had something about the visitor triggered the sun to react? No one could say for sure, but the theory gained momentum as more data poured in. If 3I/Atlas truly interacted with the solar field, it could mean that electricity, not gravity, was the real force controlling its path. And if the object could draw power directly from the sun, the next question was inevitable. How much of that power could it hold before something inside it changed forever? The closer 3I/Atlas moved toward the sun, the more it began to resemble something designed rather than born. Its surface reflected light in strange organized patterns that no natural rock should create. The spectrographs showed precise layers of material stacked like shields, each one reflecting a slightly different wavelength. That structure suggested control, as if its outer shell had been engineered to resist radiation, heat, and impact. It was no longer just a visitor from another star. It looked like a survivor of something much greater. The nickel-to-iron ratio was unlike anything seen in natural comets. It matched alloys that engineers on Earth use in spacecraft and deep space probes. These mixtures are rare in nature because they require both extreme pressure and refined separation, something only manufacturing could achieve. If 3I/Atlas was truly made of such materials, then it was not an accident of the cosmos but a product of intention. Even the way its outer layer absorbed and redirected solar energy seemed too efficient to be random. Astronomers noticed that light bounced off its surface in rhythmic flashes. At first, they thought it was rotation, but the pulses were too regular and too symmetrical. Every 11 hours, it emitted a faint shift in brightness that repeated precisely, as if following an internal clock. It might have been a natural rotation period, yet the precision raised another question. Was this rhythm simply the motion of a rock, or could it be the beat of a machine designed to endure endless space? Some researchers from the European Space Agency began testing a theory that made others uneasy. They proposed that 3I/Atlas might contain a self-regulating structure similar to an active reactor, not nuclear but electrochemical. Its interaction with solar radiation and magnetic fields could create feedback loops, producing energy without combustion. Such systems, in theory, could last for millions of years, storing and releasing power in cycles. If so, 3I/Atlas might have been built to travel endlessly, recharging itself from starlight. As these ideas spread, official agencies grew silent. NASA released no public statement and ESA avoided speculation. But amateur astronomers noticed small details that added to the unease. During long exposures, the green light around 3I/Atlas did not scatter like a gas. It pulsed from certain points, almost like energy nodes across its surface. The pattern was too complex for a random process and too stable to be chemical. It seemed to follow geometry. If this object was natural, it broke every rule known to astrophysics. If it was artificial, it meant something or someone had built it with purpose, long before humanity looked up at the stars. As it approached the sun, its calm precision felt less like coincidence and more like calculation. The universe might not just be filled with random debris after all. If 3I/Atlas was truly designed, the next question was terrifyingly simple. Who designed it, and what was it made to find? October 29, 2025. The moment scientists had been waiting for finally arrived. At exactly 11:55 UTC, 3I/Atlas reached its perihelion, its closest distance to the Sun about 126 million miles. Every space agency, from NASA to ESA and JAXA, had their instruments ready. For weeks, telescopes had gone blind from the sun's glare, but now, as the object moved into the perfect angle, a few glimpses became possible. The readings that followed would shake everything we thought we knew about interstellar visitors. Within minutes of the perihelion, solar sensors detected violent fluctuations across the magnetic field. X-ray levels spiked far beyond normal solar activity. Something massive had entered the sun's influence, and its energy signature was unlike anything recorded before. The Solar Dynamics Observatory picked up a faint burst of light that didn't originate from the sun's surface, but from above it a thin flash that appeared, expanded, and then vanished. It lasted only seconds, but it was enough for analysts to isolate the frame. The source was in the exact position where 3I/Atlas should have been. At the same time, solar wind monitors recorded an unexpected slowdown. Particles that normally moved at over 1,000,000 miles per hour suddenly dropped speed, as if something were absorbing or redirecting them. To the teams at Mission Control, it looked as though the object had switched on. If 3I/Atlas had been storing electromagnetic energy during its journey, this was the moment it released it or used it. Whatever happened in those seconds, the sun's outer layer responded. An intense wave of radiation rippled outward, temporarily disrupting satellites orbiting Mercury and even affecting signals from Earth's deep space antennas. What made this event even stranger was the symmetry of the flash. It wasn't chaotic like a solar flare. It was clean, balanced, and geometrically precise. Astronomers described it as a brief ring of light expanding from a single point, almost like a mirror reflecting a beam. Some speculated that the sun's energy had struck the surface of 3I/Atlas and bounced back, forming a reflective burst. Others suggested that the object emitted something of its own, a pulse, a reply. Either way, the sun had answered. By the end of that 24-hour window, radiation detectors worldwide showed irregular but repeating pulses. They followed a consistent rhythm that didn't match any solar storm model. For some scientists, it was a coincidence. For others, it looked like feedback, as if 3I/Atlas and the sun had entered a brief dialogue of energy. Whatever that exchange was, it left behind measurable traces in the solar wind, proof that the event had happened. When the light faded, so did the signals. The object continued its course, but the sun's surface remained unsettled for days. Its magnetic loops shifted and minor eruptions followed, as if reacting to a deep internal change. For a few minutes, the sun seemed to mirror something alien. And if that flash wasn't a reflection, then maybe it was communication. Was 3I/Atlas trying to speak through the light itself? By mid-November, when Earth finally moved out of the sun's glare, the search for 3I/Atlas began again. Astronomers from around the world pointed their telescopes toward the coordinates where the interstellar object was expected to appear. For days, the screen stayed dark. There was no reflection, no heat signature, no light curve. It was as if the object had simply vanished. At first, scientists blamed the sun's radiation for scattering any trace of it. But when data from the ESA's solar orbiter and Japan's Hisaki satellite came in, something didn't match. The predicted orbit was slightly off by about 0.3 degrees. That may sound small, but across the scale of the inner solar system, it meant a displacement of millions of miles. 3I/Atlas was no longer where physics said it should be. Something had nudged it. The next question was what? There was no sign of impact, no debris, and no visible trail of gas or dust. Even the comet-like coma it once had was gone. Instead, instruments detected a faint, rhythmic change in the solar wind, almost like an echo that repeated every few hours. When plotted on a graph, the pattern looked strangely familiar. It matched the timing of the pulses detected during the perihelion event. It was as if the object had not disappeared, but transformed, continuing to send signals through the sun's own plasma stream. Some researchers began to suggest that 3I/Atlas might have absorbed part of the sun's energy and changed its composition. Its reflective surface could have melted into a darker, energy-rich layer, making it invisible to optical telescopes but still active in other wavelengths. Infrared sensors from NASA's NEOWISE telescope hinted at something faint, a patch of warmth moving faster than before, as though the object had recharged itself. If that was true, it meant 3I/Atlas had survived its close pass with the sun and was now stronger than when it entered. Others believed it was sending out a feedback signal. Not a message in human terms, but a reaction, an energetic pulse interacting with solar radiation and echoing through space. The pattern was so precise that some called it a heartbeat. Each pulse carried a similar delay, suggesting timing, not randomness. If it was natural, it was one of the most coordinated natural phenomena ever recorded. If it wasn't, then we might have just witnessed an alien system responding to a star. Weeks later, attempts to find it again through radar and infrared failed. No one could locate a definitive object. Instead, scientists tracked distortions in the solar wind, a faint ripple traveling outward, exactly along 3I/Atlas's last known trajectory. It was as if something had left, but not entirely. Whatever passed through our system had changed both itself and the space around it. The question that haunted researchers was simple. If 3I/Atlas could shift its orbit and vanish after interacting with the sun, then what exactly had it become? And if it truly learned something from that encounter, what might it do the next time it meets another star? When the light finally faded, silence took its place. NASA stopped releasing updates and ESA's data channels went quiet. For the first time, both agencies refused to comment on what they had seen. But those who watched closely believed something had changed. The solar wind carried a new rhythm, a faint echo pulsing through space, almost like a memory of what had passed. 3I/Atlas was gone, yet its influence remained an invisible mark left on the heart of our solar system. If it truly learned to respond to light, then maybe it is still listening. What do you think? Could 3I/Atlas have been alive all along? Share your thoughts below, and don't forget to subscribe because next time the sky might answer back.